Welcome to AI Techbook. This is the Atlas production architecture playbooks for teams building with Claude. Today, the 6 agent patterns from Anthropic, the ones that actually ship in production, and the one that earned a 90% lift over a single Claude Opus call. Anthropic published an internal benchmark earlier this year. A single Claude Opus 4 call versus a multi-agent system with Opus as the lead and Sonnet sub-agents working in parallel. Same eval, same questions. The multi-agent system won by 90.2%. That's not a typo. 90% better. But here's the part most people miss. That multi-agent system also used 15 times more tokens than a regular Claude chat. If you build the wrong pattern for your task, you've shipped an expensive ghost, 15 times the bill, none of the gain. And this is where most production teams trip. They read the 90% number and they reach for the most sophisticated pattern they can find: orchestrators, sub-agents, autonomous loops. The instinct is reasonable. More sophisticated must mean better outcomes. It almost never does. The teams that ship Claude in production well are the ones who pick the simplest pattern their task can tolerate, not the most powerful one their budget can afford. Powerful patterns earn their cost only when the task actually requires them. So which pattern earns its cost? Anthropic published the answer. 6 canonical patterns: prompt chaining, routing, parallelization, Orchestrator-Workers, Evaluator-Optimizer, and autonomous agents. They're ordered from cheapest to most expensive. Each one earns its keep under specific conditions and fails under others. Watch this: 6 patterns, 6 concrete examples. By the end, you'll know exactly which one your next agent should be and which one your team should walk back from. Before the 6 patterns, one distinction Anthropic locks in early. A workflow is when you, the engineer, decide the path. The LLM is a node in your code, but the control flow belongs to you. The shape of the request is known in advance. Example: a contract review pipeline that calls Claude 3 times in a fixed sequence: extract, then analyze, then summarize. An agent is when the LLM itself decides the path. It picks the next tool. It decides when to stop. It recovers from its own errors. The control flow belongs to the model. Example: an autonomous coding agent that reads a GitHub issue, navigates a codebase, runs tests on its own, and submits a patch with no scripted steps in between. 4 of the 6 patterns are workflows. 2 are agents. Workflows are predictable, cheaper, easier to debug. Agents are flexible, more capable, dramatically more expensive, harder to trust. Most production teams need a workflow. They reach for an agent. That's the second mistake. Most teams need a workflow. Which workflow? That's the next 4 scenes, starting with the cheapest one most teams skip past. Pattern 1, prompt chaining. You decompose a task into fixed sequential steps. Each LLM call takes the output of the previous one as input. The chain is something you, the engineer, wrote in code. It's the simplest agentic pattern, and most of the time, it's the right one. Concrete example: you're building a contract review tool. The user uploads a PDF. You want a clean executive summary. A single prompt that says summarize this contract gives you generic, watery output. The model is doing extraction, analysis, and writing all at once, and it does none of them well. A chain breaks that apart. First call extracts the structured entities, the named parties, the effective dates, the dollar amounts, the governing law, the jurisdiction. Second call takes those entities and finds the dependency clauses, termination triggers, auto-renew language, indemnity caps, exclusivity terms, change of control provisions. Third call writes the executive summary using the entities and the dependency clauses as grounding in the format and tone your business team actually wants. 3 calls, each one focused on a smaller, sharper job. Each one cheaper than a giant single prompt, because each call has less to think about and a smaller, more structured answer to produce. And the final summary is dramatically better, because by the time you write it, you already have grounded structured input, instead of asking the model to extract and reason and summarize all in one pass. Anthropic's exact framing: trade off latency for higher accuracy by making each LLM call an easier task. That's the whole pattern in one sentence. Use this when the steps are fixed and you can name them ahead of time. Don't use it when you don't yet know what the steps are. That's a different pattern entirely, and we'll get there. Pattern 2, routing. You classify the input first, then send it to a specialist. The classifier is cheap. The specialist is whatever the input deserves. Concrete example: You're running a developer support chatbot for a Claude API integration. 4 kinds of questions come in. Simple lookup, where do I find my API key? Haiku can handle that in 1 second for fractions of a cent against a docs index. Conceptual, what's the difference between tool use and tool result? Sonnet handles that cleanly with a focused docs prompt. Code debug, why does my streaming response stall at exactly 4,000 tokens? That's Opus territory, because it needs deep reasoning over a stack trace and the model's response format. And the 4th branch, escalate to a human, because the question is account specific, billing touching, or compliance watched, and an LLM should not be the one answering it. To 6-star eluding means a Haiku call goes first. It reads the question and labels it lookup, conceptual, debug, or escalate. Then your code branches to the right downstream handler. Each branch gets its own prompt, its own model tier, its own tool list, its own temperature, even its own response format. The win is twofold. First, you spend Opus dollars only where Opus is actually needed, which can cut total cost by an order of magnitude on a high-volume chatbot. Second, each specialist branch has a tighter, more focused system prompt because it only handles one category, and tighter prompts produce sharper answers. Use routing when your inputs cluster into distinct categories with distinct optimal handlers. Don't use it when your inputs are genuinely varied, and don't cluster, because a bad classifier is worse than no classifier at all. A wrong route sends an Opus grade question to Haiku, and you've spent latency on a worse answer. Routing is still cheap, one classifier, one specialist. What changes when every input needs every specialist? You stop choosing and run them all at once. Pattern 3. Parallelization, you run multiple LLM calls at the same time. There are 2 flavors, sectioning and voting. They look similar from the outside, but they solve different problems. Sectioning first. The subtasks are different but independent of each other. Concrete example, code review. You've got a pull request that touches 8 files across the codebase. One giant prompt asking Claude to review all 8 files will drop attention by file 3. By the end of the prompt, the model has half forgotten what it saw in the first file, and the security finding it should have caught in file 7 slips through because it ran out of working budget. So instead you fire 8 parallel calls, each one reviewing one file with full attention and full context. Then a final aggregator call collects every finding into one ranked list of issues. Anthropic's own guidance, parallelize tool calls and you cut total time by up to 90%. Same total tokens, dramatically faster wall clock, and dramatically better quality findings because no single call is overloaded with too much input at once. Voting next. You run the same task multiple times and combine the answers. Concrete example, content moderation. You've got user-generated text, and you need to decide if it's harmful before publishing. You run 3 parallel calls, each asking, is this harmful, yes or no? If at least 2 of the 3 say yes, you block. Voting smooths out the noise of a single call making a borderline judgment, the kind of edge case where one call might say yes and another might say no on the same text, depending on a coin flip of sampling temperature. With 3 voters and a threshold, that noise stops mattering. Use parallelization when subtasks are truly independent, when no subtask needs the output of another to do its job. Don't use it when tasks depend on each other sequentially. That's prompt chaining territory, even if you wish it were parallelization. Parallel calls on dependent tasks just means parallel wrong answers, faster, and you still have to chain at the end to recover the order. 3 workflow patterns down, cheap, deterministic, debuggable. Now we cross into agent territory, and the 90% number you saw at the start. Quick break. The next pattern is the one Anthropic uses for their own research agent, the architecture that earned the 90% lift this episode opened with, the hero pattern. Before we get there, hit subscribe to AI Tech Book. The Atlas drops one production architecture playbook at a time, and you don't want to miss the next one. Tool design, MCP, Claude code config, real production episodes. Back to the patterns. Pattern 4. Orchestrator-Workers. This is the hero pattern. The architecture that produced the 90% lift this episode opened with. The idea, a lead agent reads the task and decides at runtime how to decompose it into subtasks. It then spawns specialist subagents, one per subtask, and they work in parallel on a shared workspace. The lead checks in mid-flight, adjusts, sometimes spawns more subagents based on what came back, sometimes prunes ones that are wasting effort. The shape of the work is decided by the model, not by your code. This is the part that trips people up. It looks like parallelization, but it's not. In parallelization, you, the engineer, write the split logic in code. The number and shape of subtasks is known in advance. You decide there will be 8 files and 8 parallel calls. In Orchestrator-Workers, the LLM itself decides what the subtasks are at runtime. You don't know how many subagents will spawn, or what each one will do, until the lead agent has read the task and reasoned about it. The decomposition is part of the reasoning. That's the whole distinction. Anthropic's research example is the cleanest one. The task lists all board members of the information technology S and P500 companies, around 60 companies. A single Claude-Opus call tries to do it sequentially and runs out of attention halfway through. Board listings are public information, but pulling them for 60 companies in a single context blows the working memory budget. The multi-agent system, Opus as lead, Sonnet as subagents, decomposes the task differently. It lists the companies first, fans out a subagent per company. Each subagent finds the board members for its one company, and then the lead aggregates the results. That's how Anthropic got 90.2% better than the single call. Same Claude, same evil, just a smarter architecture wrapped around it. Here's the catch. This pattern uses 15 times more tokens than a regular chat. Anthropic's own data, token usage alone explained 80% of performance variance in their evaluation. You're paying 15x for a flexibility you only need when the subtasks really are unknown ahead of time. If you can decompose the task ahead of time on a whiteboard, you don't need this pattern. You need parallelization, which costs a fraction and produces the same answer. Use Orchestrator-Workers when the decomposition itself requires reasoning, when you genuinely don't know up front what the subtask will be. Don't use it when the subtasks are predictable. If they're predictable, you wanted parallelization, and you're paying 15x for nothing. The pattern that earns 15x is the pattern that needed 15x Orchestrator assumes done is obvious. What about task where the bar is? Does it pass our spec? Evaluator-Optimizer comes next. Pattern 5. Evaluator-Optimizer. 2 LM roles, 1 generates. 1 evaluates. They loop until the output meets criteria. The evaluator's feedback informs the next generation pass. Think of it as 1 Claude writing and 1 Claude critiquing, with the critique getting handed back as input. Concrete example. Marketing copy generation with brand voice constraints. The optimizer Claude writes a paragraph of product copy. The evaluator Claude reads it against a brand voice rubric. Tone matches the brand's warm, confident register. Specificity is high. No marketing superlatives, mentions of the right product features. No claims the legal team hasn't cleared. If the evaluator says no on any criterion, it explains why in concrete terms. This paragraph uses the word revolutionary, which violates the no superlatives rule, and the optimizer rewrites with that feedback in context. Loop until pass. Usually 1 or 2 iterations is enough. The pattern earns its keep when 2 things are true. First, the evaluation criteria are clear enough to articulate. You can write them as a checklist that you'd hand to a human reviewer. Second, the LLM can credibly judge those criteria, better than a regex or a simple heuristic could. Code review against a security checklist is a great fit. Literary translation refinement is a great fit. Fluent prose in the target language is something the model can judge. Generic is this good is a bad fit. Without clear criteria, the evaluator loops indefinitely, and the token bill mounts for no quality gain. Use it when articulable criteria exist and feedback measurably improves output. Don't use it when you can't write down what good looks like. The loop becomes a token bonfire with no quality floor. Evaluator-Optimizer still keeps you in the loop. The 6th and final pattern removes you entirely. Pattern 6. Autonomous agent. The LM decides everything. Which tool to use next. When to stop. How to recover from an error. Your code is a loop that hands the LLM the latest tool results and asks, what now? There is no scripted path. There is just the model, the environment, and the loop between them. This is the pattern behind Sestobi Bench, Anthropic's reference benchmark, where an agent reads a GitHub issue, navigates a codebase, edits files, runs tests, debugs the failures, edits more files, and submits a patch entirely on its own with no scripted steps. It's also the pattern behind computer use, where Claude moves the cursor, takes screenshots, clicks on buttons, types into form fields, and operates a desktop application end-to-end without any scripted automation telling it which pixel to click. Both are real production-grade examples of full LLM autonomy. Autonomous agents are the most capable pattern in the playbook. They're also the most expensive, the most unpredictable, and the hardest to trust in production. Token usage compounds because every loop iteration adds context, and every wrong turn the agent takes costs real money before it self-corrects. Cost is not the only risk the action surface is. 3 things they need that you cannot skip. First, a sandbox. Compounding errors are real. An autonomous agent loose in a production environment can delete the wrong file, send the wrong email, or charge the wrong card before you notice. Sandbox first, always. Second, guardrails. Explicit limits on what actions are allowed, no shell commands outside this directory, no API calls outside this allow list, no spend over this dollar threshold per session. Third, human in the loop checkpoints for any irreversible action. If the agent is about to delete data, push to production, or move money, a human approves before the action fires. No exceptions. Use autonomous agents when the problem is genuinely open-ended, when no fixed workflow could cover the space of possible solutions. Don't use them when you could have written a workflow. Production paths that need predictability, billing, identity, anything compliance watched, should not start as autonomous agents. Earn trust first with the simpler patterns, then escalate slowly with observability and rollback in place. 6 patterns mapped. But there's one trap that explains why most teams ship the wrong one, and Anthropic documented it for us. Here's where most teams go wrong. They read about the 90% lift, jump straight to Orchestrator-Workers, build something elaborate, and ship a 15 times more expensive system that produces the same output a 3-step prompt chain would have. The pattern was wrong for the task, but the team didn't know that until the bill arrived. Anthropic published the failure modes from their own multi-agent system, the same one that beat single Claude by 90%. 4 documented patterns to watch for. 1. Sub-agents spawn for queries that needed exactly one call. The orchestrator over-decomposes a simple task, fans out work that didn't need fanning out, and aggregates results that could have been a one-shot answer. 2. Sub-agents duplicating each other's work. 2 sub-agents end up doing overlapping research because the orchestrator's task split was sloppy, and you pay twice for the same finding. 3. Endless web searches for sources that don't exist. A sub-agent looking for something that isn't on the internet keeps searching, refining its query, searching again, burning tokens on a fundamentally impossible task because no one told it when to give up. 4. Sub-agents picking SEO bait content farms over authoritative sources because they didn't have explicit instructions to prefer authoritative ones. The answers come back confident and wrong. These aren't theoretical risks. They're what Anthropic's own engineers saw and had to engineer around when they built the system that beat single Claude by 90%. The lesson they codified: success in the LLM space isn't about building the most sophisticated system. It's about building the right system for your needs. And single optimized LLM calls with retrieval and in-context examples often suffice. Default to the simplest pattern that does the job. Only escalate when you can measure the next pattern doing strictly better on your eval. If you can decompose in advance, you're paying for flexibility you don't need. So 6 patterns, 1 trap. What does this mean for your job specifically? Architect, developer, technical PM, different stakes, same playbook. If you're an architect, the number that matters is the 4x to 15x token multiplier. Map each of the 6 patterns to your cost center budget. Document which patterns require which approvals. Orchestrator-Workers and autonomous agents need explicit sign-off because their cost shape is qualitatively different from a single call. Not a bit more expensive, but 10 to 15 times more expensive per request, with token usage as the dominant driver. Treat them as a different line item in your forecast. If you're a developer, your default starting point is prompt chaining or routing. Both are deterministic from your side, easy to debug, cheap to iterate on, and produce traces you can step through when something breaks. Only escalate to Orchestrator-Workers when you've measured the simpler pattern actually plateauing on your eval. Not when you suspect it might, but when the numbers show it on a real benchmark you own. Never start an autonomous agent. Earn it. Earn the trust first with workflows, then graduate. with sandboxing in place. If you're a technical PM, the question your engineers should be able to answer for any agent in your product is this: which of the 6 patterns is it, and what eval shows it earning that pattern over the simpler one below it? If they can't answer both halves of that question, they don't actually know what they shipped, and neither do you. Make the answer a precondition for the launch. 3 roles, 1 shared question, which pattern, and what eval shows it earning that pattern. Now let's see all 6 together, one final time, in cost order. 6 patterns in cost order: prompt chaining, routing, parallelization, Orchestrator-Workers, the 90% pattern, Evaluator-Optimizer, autonomous agent. Pick the simplest one that earns its eval on your task. The pattern that earns 15x is the pattern that needed 15x, not the one you reach for first. If you can decompose the task on a whiteboard ahead of time, you don't need an orchestrator. You need a chain. Start simple. Escalate only when the eval says you must. 6 patterns. Now the close. Thank you for watching AI Tech Book. 6 agent patterns ordered by cost. The pattern that earns 15x is the pattern that needed 15x, not the one you reach for first. If this changes how you think about Claude in production, share it with one person. Subscribe to AI Tech Book for the next Atlas, tool design, and MCP integration.